In exercise 4b, we will use stacking, and we have to install several packages here. So for the approach that I will use, which is the same as in the lecture, we have to install all these packages and then import them as well. Then we set the controls. We will use cross validations 10 times. We have to save the predictions. Then we will define the list of algorithms that we want to use, which is the same as from the lecture. So linear model, tree model, random forest, bagging, boosting. This is AdaBoost, I guess. Lasso and ridge regression. Then I will build this model using the caret list function, which is the regression model in this case. And I will set method list to the list of algorithms that we defined. So let's run this. This is actually taking some time. And this error message actually looks horrible, but it's not that bad, so we can ignore it. So it will actually take that long because it has to train all the models using tenfold cross validation. So this will take some time. Now the training is done and we get the results and the summaries, which we called here for all the models, which we could inspect now. But let's build our stacking model first. And this will now contain all the models that we have trained before. The method equals to rf tells the caret stack which base model I want to use for the stacking, because if you remember from the lecture, then the linear form with the weights that we've discussed, so which was just a linear combination, a weighted linear combination of the predictions, is just one possible algorithm that we can use as a model for stacking. We could also build another algorithm, for example, a random forest for stacking. So we take the predictions from the models that we've trained before, and then we will pass them into a random forest that we train as our stack model. And this is what we do here. So method is equal to rf, and the metric should be RMSE, so we can compare with the above. And the control setting are as before. And if we print this, then we can actually see here for the mtry parameter set equal to 2 yields the lowest RMSE of 2.93. And if we now compare this to the RMSEs of all the other models that we've trained before that produce the inputs for the stacking, and we have a look, for example, at the mean, then we see with 2.93 we're not that bad. We could also it could be better, but yeah, I think that's just how it is. It doesn't always go according to plan. I think it was uh, similar in the lecture that that what we wanted to show uh, didn't really work out. So basically, stacking should improve the the result should be better than its components here, but unfortunately, this is not the case for now, or not. It's not always the case, but in some cases, it's better. For example, it's better than the linear model. Um, but here, a simple random forest is an average and slightly better. Also, the Zoo regression.